Hang on a second. The robot vacuumer just started. I'll quit that so we don't have to have that in the background.
While he's but we're waiting for him to come back, one thing I discovered I had to do is I'm on the beta stream of my home network provider, and they usually do updates like around 2 in the morning. So I got them to turn it off for this week. It's not usually an issue. So, all right, why don't we get started? Welcome to Six Man. This is our second session. Next slide. I think you've seen this. I think you've seen that. And this was the agenda from the first session. We didn't get to Linda Dunbar's talk, so that's going to be the first talk now. Next slide. And then we have a report on the SR compression design team. There was just, many of you may have been in the spring working group that just preceded this, and there was a pretty big, long discussion about this. We don't want to repeat that discussion here, so we'll keep it to the 15 minutes and try to limit the discussion to clarifying questions. And then we have 2 working group drafts, the minimum path MTU hop by hop option and the alternate marking method draft. And Tom Herbert was not able to attend, so we will not be having a session on his draft. So any questions? Hopefully our speakers are here.
I guess, Linda, if you can just unmute yourself, I'll get the slides up for you.
Can you hear me?
We can hear you.
Oh, great, great.
There we are.
Yeah, thank you. So here I'm going to talk about IPv6 based solution for the 5G edge computing sticky service. Next page, please. So a little bit of background. So in 5G edge computing, 5G edge computing is a project in 3GPP SA2 under the project 23748. So in a nutshell, there is a 5G system on the left-hand side of the dotted line. We have cell tower, we have packet session anchor, and we have distributed functions for 5G system. There is an interface to the local data network, they call LDN for edge computing. There are many use cases being identified in 3GPP. For example, they have a manned aerial vehicle requiring like a drone to be managed by the controller. They have virtual interactive conferences. The common characteristics of this 5G edge computing is that there could be many backend servers for the same application, and they are very close to in proximity. Next page, please. So because IETF, we're looking at from IP layer. So what do we see from IP layer for the local data network? For all those edge servers, multiple edge servers for one application, today the trend is using the Anycast instead of having multiple local DNS resolvers in each LDN. There are many, many benefits of using the Anycast. Not only it can balance the traffic across different servers using the utilizing the network condition. It's actually basically being able to utilize the routing layer information to achieve better load balancing, and to remove the single point of failure at the DNS resolver or the application load balancers. Also, that the many client or user device may use their cached IP addresses for extended period of time. So if we use the DNS server at each LDN, some of the clients may not even bother to do inquiry. Of course, using Anycast among multiple servers in close proximity also bring up issues, like because they are so close to each other for 5G network. One application server in LDN1 maybe is very close to the one in LDN2. So the network distance difference is not significant enough to balance out other factors, like for example, higher capacity, or maybe some side may be more preferred than others. So there are other issues brought up by this. Next slide, please. So the sticky service in the 5G edge computing is referring to the scenario where the edge servers are very close to each other. When the user device, UE, initially anchored to the PSA1, packet session anchor 1, moving to a second cell tower and to be anchored at a PSA2. For this particular UE, the service is better to be served by the original server, so they call it sticky. So in a way that if you look at the local data network 2, there will be many traffic from different UEs, different users, or different applications. And even from the same user, it may have multiple applications. All those users, they are actually may resolve to, for example, IP3 may be anchored into the edge application server 2, versus the newly migrant UE1 need to go to LDN1. So in the 3GPP SA2 edge computing project, there are many proposed solutions, and we find that actually IPv6 provide a very elegant solution. That's why we want to present here to get people's feedback. Next slide, please. Next slide. So IPv6 has this elegant, very convenient way having this destination extension header. So this is the flow. When the UE traffic coming to anchored to the PSA1, that goes through the eNode B, and the GTP tunnel is terminated by the PSA1. So after the traffic coming out of PSA1 to the ingress router to the local data network, we'll have source and destination based on the criteria in choosing the closest Anycast server, and it will end up to go to the Anycast server, say S1, attached to the router R1. We call R1 being the egress router. And we assume that for the Anycast, for the sticky service, it's not for all services. So there will be application manager informing the routers of the services that they need to be sticky. So when the S1 server coming back with the response back to the source, the R1 basically insert, use the ACL to filter out the service and insert the sticky service, sticky destination sub-TOV inside the destination extension header. So then the traffic come back to the UE, and in the UE, it has the expected behavior to copy the destination extension header from the received packet to the subsequent packets for the services and for the flows that need to be sticky. So with that, when the UE moved to anchor to the PSA2, the traffic comes to the router B, and the router B will be able to be informed by the sticky service management system to filter out those packets and be able to filter out the original egress router, which is R1. And with that information, our router B can either use a tunnel or use segment routing to forward the packet to explicitly to the router 1 to achieve the service to be sticky to the original server. Next page, please. So here's the sticky service sub-TLV. There's a sticky type. Right now we just define as just to represent. We have two types. One is the egress router can be identified with 32 bits identifier, even if the router, egress router is using IPv6 address. We assume that within some environment, the local data network is managed by one provider. They can use a shorter identifier to represent the egress router. There could be, if that's not the case, say in the heterogeneous environment, you have to use the actual address. Then the sticky type can set to 2. Then with that, you will use the tunnel endpoint sub-TLV, which is defined by the tunnel in cap draft to represent the egress router. And we put the sticky service, sticky destination sub-TLV in the destination extension header. Next page, please. Another option, so this is hope to get some feedback from the experts here. There's also the IPv6 routing extension header. So based on the definition of the routing extension header, is to list the number of intermediate nodes to be visited on the way to the destination, packet destination. So in this case, that'll be the egress router to be one of the nodes to be visited. So we'd like to get some feedback. Is it okay, like routing extension header versus destination extension header? Do people have any opinions on that?
Ron?
What you're trying to do is send information from destination. The destination option is the right thing for that. Routing header would only be appropriate if you really wanted to steer the packet along some specific path, and I don't think that's your primary goal.
That's right. Okay. Thank you very much, Ron. So we'll eliminate this option. We'll just take the destination header. Next page.
Okay, we also have Eric in the queue.
Oh, okay.
I was going to agree with Ron. I think if you give it, if you put it in the destination header, then you open the possibility that it could still be delivered to the endpoint at was it L2 or whatever, but that L2 could open a proxy session for certain applications and maybe proxy it back to L1 if you leave it in the destination header.
Thank you. Okay, next page. So this is for when the user device, like older version, doesn't do what 3GPP spec is doing. So it doesn't do anything with the incoming packet, doesn't copy the destination option header into the next subsequent packets. This is one option to achieve the sticky service. This required 5G management system cooperation, like through the network exposure function. So when the session manager is determining that this UE1 need to be re-anchored to a new PSA, usually they have the handshaking period to maintain the service continuity. So with that, 5G management system can notify the local data network management system that this particular user is to be re-anchored. And then with that, this router, ingress router, will be able to find out through his routing protocol, find out where this PSA2 is attached, and be able to send this sticky service sub-TLV information to the new ingress router. So that's this service without dependence on the UE behavior. Next page. Here is another case where there's no assistance from 5G system at all. So if local network, data network doesn't get any assistance from 5G core, then the ingress router, every time he receives the packet with the destination extension header embedded, he needs to inform his neighboring routers. Assume that, say, 5G site A, there's RA there, has like 10 neighbors, immediate neighbors. And then he needs to be able to send his this destination header information to all the neighboring ingress router. So all those ingress router will have the ACL to filter out the sticky service IDs. And if he ever receive a packet which matches with the sticky service ID and the float label from his neighboring router, it will start to extract the destination egress route, original egress router from the destination header, and then form either tunneling or SR approach to forward the packet to the original egress router. Next page. Okay, so as I said earlier, the purpose is to get feedback from the experts here to validate this approach actually workable, and we are looking for feedback. If it's workable, we can propose this to 3GPP to show for IPv6, actually the solution is very elegant instead of many other proposed solutions out there. Or in addition to, I should say.
Okay, so we're a little over time, but if you have, if there's some quick comments, if not, we can take it to the list. All right. Well, thank you, Linda. And
Okay,
yeah,
thank
but
you.
please encourage people to comment on the list.
Okay.
Okay, let me get the slides up here. There we are. Let's see. So, Wei Chang, please, the floor is yours.
Do
We
you hear me?
We can hear you.
Do I need to open the video?
It's up to you. We're happy to see your lovely face.
Okay, I see the rule in 6-man group. You required to open the video, right? Okay. So I think the Spring chairs, Spring Working Group chairs suggested that we should represent the SR compression design team report for 6-man to keep everyone on the same page about the work. And 6-man chairs kindly approved our lead application. So thank you very much. Here I'm very glad to report the status and the plan on behalf of the team members. Next page. So the overview of the design team is shown in this page. The design team was set up at this July, and we have 8 team members from Huawei China Mobile China Telecom, Cisco, Juniper, SGM, Nokia, and ZTE. We have a mail list. Now it's private, but the archive can be read by anyone. About the documents, if we deliver the internet drafts, we will put them in the data track of IETF. And we also have a GitHub space to store the meeting minutes and documents. The link here is open for anyone. For the meetings, typically we have a weekly meeting in order to submit the requirement draft by IETF 109. In last 2 months, we run twice meeting per week. I think the team members in the design team offer great efforts on the document, and we have already submit the requirement draft on time as we promised. Here, I think we should thank all the team members. Next page. For the scope of the design team, it was defined very clear by Spring Working Group chairs. The design team is produce rough consensus outputs to the working group on 2 topics. One is the requirements for the compression solution. The second is the comparison or the analysis document to the working group. And here I would like to point that all the draft, even if it is agreed within the design team, it is still is individual draft for the working group. So that is the basic scope of the design team. Next page. And the working group also hope we can answer the following 2 questions. One is whether are several proposals already standardized, whether is there value in picking one or some. I don't think we have touched those questions. Now we only focus on requirements. But the working group of Spring also very nice. They consider if a design team can not get agreement on those questions, that is also acceptable to the chairs. So that is some additional information. Next page. So for the design team, I think we have a rough plan. First stage during IETF 108 to IETF 109, we hope to output a requirement draft. I think we have achieved this plan. And the second is during IETF 109 to IETF 110. We will do some analysis on several proposals and output initial analysis draft. So this is a basic plan. Next page. Next page.
Oh, there we
Yeah.
are. Sorry.
Yeah, the process of the design team so far so good. I think we have achieved what we promised till now. We kicked off since end of July, and till now we have had more than 20 meetings. During those meetings, we drafted the 2 versions of the requirement, and you can access the current version of the draft through the link in this page. And we are calling for the review, and we also hope 6-man working group can give your comments to us, so that we can resolve those comments as soon as possible. And
So
we hope
clarifying question, just so the last milestone, that's a year from now? Because it says 2021.
Oh, yes. Yeah. Sorry. That should be 2020. It's my fault. Sorry. Yeah.
Okay, much
Well,
better.
we have
Thank you.
so sorry for that. Yeah.
Yeah, it came up in the chat room, so
Yeah. Okay. Next page. Okay, here is an overview of the requirements draft. There are 3 main parts of the requirements. The first aspect is SRB6 seed list compression requirement. The second aspect is SRB6 specific requirement. And the last one is protocol design requirements. As well as we have an appendix in this draft, which contains some requirements without unanimous consensus within the design team. In the figure, the item with the red flag is those which have been agreed within the design team. The ones with green flag is those without unanimous consensus within the design team. So next page. Let's see some next step plan. Next page. Okay, so for the requirements draft, we hope to finish it soon. We hope to gather the comments from a working group in next 1 or 2 weeks. And within the design team, we will have some discussion and resolve them soon. For the design team, we hope to generate a new revision by end of this year, and we hope to submit the version on time. So next page. For the analysis draft phase, I think the design team will provide a list of proposals at first. I think the list will be posted to IETF in January 2021. And we hope to submit initial analysis draft to IETF before next meeting. So that's all. That is basic status and plan for the design team.
okay, thank you. We have a little time for some comments, though. Let's not. There was a big discussion in the spring working group, so let's not repeat that. But so, Ron.
First, thanks to Wei Ching for preparing the proof. It's been a lot of work. Second, people might get excited that the document looks incomplete. There are requirements that are still in the open state that aren't in the document. So if it looks incomplete, don't get too nervous about it yet. Second is a question probably for Eric Klein and for you, Bob and Ole. We've had an open call for adoption on the CRH draft since late May. It's waiting on this design team. It looks like the design team won't be back until IETF 110. Now, I have customers who are interested in the CRH, but could care less about the SRv6 control plane. They're provisioning their boxes from a controller that does everything, so they don't want SRv6 control plane or anyone else's. Sooner or later, when do we make the decision to adopt CRH? For no reason other than for the people who are using it and not using any IETF routing protocol.
I don't have a really good answer for you, Ron. I sort of was thinking the same thing when I was listening to it in the spring presentation,
Maybe it's a question for Eric.
Eric, do you have any comments?
Yeah, well, I was going to try to add myself to the queue, but maybe I'll just use the unmute button. I think it's important to note that the SR design team, while it may be going slow, it does seem to be working. It's just maybe not working fast. But we had talked about there being some other options, like whether or not 6-man needs to adopt SCRH, or whether or not you just need a routing header subtype.
Yes, I'd be happy. That would be a good place to start.
So, I think we could consider. I could double check with routing ADs and see if how they feel about that. I don't personally have any problem with that at all. So,
okay, sounds good.
Yeah, I'm also hoping that by watching what the design team is doing, we can sort of try to figure out where they're heading, and that may help too.
Does the design team look like it's going to need a new routing header subtype? Or sorry, I guess it's string in general.
So, excuse me, couldn't I give some words on that?
Please.
So, yeah, from a design team side, I think the scope for us is very clear. One is to output a requirement draft, and the second is do some analysis on the proposals which have been submitted to IETF page. So from my point of view, we should keep study on those different proposals. And if CRH is adopted by 6-man, I don't think there is a direct relationship between the draft output to IETF. And as I just mentioned, any draft output from design team, they are all the individual draft. That is not any agreement for the working group or for IETF. So I think design team just to give some, I think maybe some guide or information on the direction. I don't think that should be used as some justification or something like that. Thank you.
Okay, so let's try to get through the rest of the queue. So ask Darren, I think you're next, but let's try to keep the comments short.
Just on the context of whether the design team thinks that there's a new routing header subtype needed, the design team is just focused on building the requirements and then analyzing the proposals, Eric. So I don't think you're going to get anything on there won't be a design of a solution by the design team. It's just the requirements and analysis of the proposals that it's going to produce.
Okay. Chen?
The progress of the design team is going well, and we are going to finish the discussion as soon as possible. But it's not the consensus right now, and it's also not the requirement of even the spring working group. So I don't think it's the right time to adopt any solution right now. Yeah.
Okay, Andrew?
So what I kind of want to say is, looking at the whole CRH thing, right now we're in a situation where this has been around for a number of IETFs, and we've moved from requirements documents to a design team to et cetera, et cetera. The fact is that this code is shipping today. It's in production code, and there are people like myself who need it. And we need it in order to deal with geopolitical issues, for one thing. It's critical for dealing with geopolitical issues and avoiding the suppression of internet freedoms. That's what we're using it for, I'll be blunt. And by delaying this any further, all that we are doing is driving protocol development further outside of the IETF, because the development is not going to stop. This is simply too critical. And I would argue that that is not in the interests of the technical community. It is not in the interests of the IETF. It is not in the interests of the vendors, who their very customers are the operators. And we have a massive demand for this on the continent, where we have to have a working solution, which is what CRH gives us, to deal with authoritarian states who wish to play with traffic. This is how we deal with it. And I am pleading with this working group to let's stop the delays, because CRH, as we've said, is a building block. It is not tied to SRH. It is not tied to SRv6. Let's treat it as such and get this thing adopted, so that we've got a protocol that is developed within the IETF rather than entirely outside of the auspices of this body.
All right. Thank you, Andrew. Understood. Okay, Wim? Go ahead.
You are very faint, Wim.
Yeah, we can't hear you.
Do you want to see if you can fix your audio issues, and then we go to Safar and then come back to you, Wim? Is that okay? And when you're at the head of the queue, please unmute yourself a couple of seconds ahead of time, because it takes a little while to get going. Okay, Safar disappeared. Wim, do you want to try again, or otherwise we'll go to Senbin?
Nope. Okay.
Okay. This is Zheng Bin from Huawei. So I first, I very appreciate the design team's work, because I know they will try very hard to propose this requirements draft. The second point, I mean, so that if the adoption of this, the CRH, and the relationship of the adoption and the requirement has been discussed between the routing area and the inter area. I think if the work is being done for the adoption, I think this not only the inter area, but it also should be coordinated with the routing area and the spring working group. The third one, I want to clarify. I think in the adoption, the first adoption, the process of the CRH, even without the requirement of the design team, there's still of the comments and the challenge of the existing the CRH work. Because, for example, I want to know the what's the ID to be identified, and also besides this ID identified, also the existing the functionalities such as the VPN, L2 VPN, L3 VPN, how to be supported with CRH. We need to understand the whole framework. I mean, for the solution is not only the data plane, but also how we need to understand the whole picture. Yeah, so that's my the points.
Okay, thank you. So Wim, let's see if your audio works.
Can I try one more time or not? Do you hear
Yes.
me or not?
Yes,
can
we
hear
can hear you.
Okay, forget it.
No, oh, he couldn't hear us.
Oh,
We could
okay.
hear him. Okay.
All right. Well, thank you. Interesting discussion. We will have some follow-up with our ADs after the meeting is over.
So next presentation, I think that is Bob and Gori on the.
I think it's going to be Gori.
Excellent. Gori, the floor is yours.
Well, first of all, can you hear me?
We can hear you.
Excellent. Okay, so this talk is one that's on a draft that's jointly with Bob. I'm going to do the talking. We're being helped by Anna, who's doing some data experiments, which we'll talk about a little later. The draft is the IPv6 minimum path MTU hop-by-hop option, and we're at revision 4, which we'll talk about in a few slides. Please go ahead. The background is we assert that PathMTU discovery isn't working well, and we'll explain that in some measurements in a few minutes. The hop-by-hop option is being proposed as an idea to exchange the PathMTU that routers have. As a probe packet is sent across the network, they add the PathMTU, and we think this has got a better trust relationship than the current use of PTB messages. And before you all come to the mic to complain, yeah, we know it doesn't work in all places, and we'll prove that in a few minutes. Next slide. This is the shape of the hop-by-hop option. If you haven't seen this before, the BB and C lines just underneath the packet are the most important. In other words, if you are an IPv6 router and you get this hop-by-hop option, you can skip it and continue processing. We prefer you to fill this in because it will tell us things, but we're aware that some routers won't do this, and that's quite okay. We'd prefer you to update it, so the information here is about the minimum path MTU that you see, and the second field returns back what the other endpoint finally saw at the destination back to the source. So this is a fairly small piece of information, just 2 bytes, and it helps us a lot. Next slide. What have we done when we revised 03 and 04? We did 2 revisions in the last period, and our 2 revisions did a fairly big rewrite of the words. Our original words were good, of course, because we try to write good words, but they're now actually good and readable by others, which is a real advantage. We think so. If you prove us wrong, please read it, because my final slide is going to say read this draft, because it's now structured in a way which presents the different parts to different people who are interested. We talk about what the router has to do, we talk about what the source has to do, we talk about what the destination has to do, and we talk a little bit about how to use the information. One of the things we did when we rewrote it was we at Aberdeen looked a little bit into how the API worked in FreeBSD for using this information. And that was a helpful thing to do, because it helped us understand a little bit more how the option could actually be used higher up the stack. And DPLP MTUD, which we've loved trying to say for several years now, is now an RFC 8899, which is arguably much easier to remember than the long acronym. So we've referenced that, and maybe in future we'll just call it RFC 8899. Next slide. One of the things that was exposed by looking at the API was there's probably 2 ways to use the information that's in the option. The first way is basically in the way PathMTU discovery has traditionally used it. You get a packet back with some information, you use it at the IPv6 layer, and you directly change the cache or entries you have for PathMTU for the flows that you've received these messages for. The other way you can use it is as a probe in PLP-MTUD, in which case the contents of the option is passed up to the upper layer. The upper layer then reads the options data. It can validate the options data because it knows more about the contents of the packet which it receives as a probe. And then highlighted in green, there is a way for this upper layer protocol to then throw away the option data if the packet isn't validated. It seems subtle. You probably have to read the draft to understand it properly. But what this means is if the upper layer processes the hop-by-hop option data, then you can have a better security method because the hop-by-hop option data can't be easily injected off path if this happens. That simple check of can you deliver it to the upper layer? Is the upper layer expecting this packet with the option attached to it? Provides a lot of extra security. And by thinking this through, particularly the two different ways you could use the hop-by-hop option, we came up with a much greater security considerations section, which I think I would like to suggest the document is also probably ready for greater review, maybe even publication soon, because we have a security considerations section that talks about the network layer processing. We talk about the validation of the options data, and we talk about the impact of middle boxes. A nice discussion of how the method works. I guess next slide. I tried to go quickly because we've got slides also on experiments. The hop-by-hop option experiments have currently been based around some IPv6 probes, which look like this. It's a small form PC that's running the probe software. We have 6 of these probes in various places, 2 in the USA, 2 in the UK, 1 at home and 1 elsewhere. We're looking for more people who want to have probes and join in the probing and discovery of where this works. So we'd really love you to contact us, particularly if you have IPv6 interest and you're interested in a larger MTU, or you might even be able to host one of these. So please talk to us.
Because we found out that the probe that I have at my house is fairly limited in MTU.
Limited MTU and also in other ways. If we go carry on, Bob. Next slide. Right. So first set of results, MTU. Okay. So what did we find out? We did a lot of experiments for MTU to figure out what MTU we saw running from these probes to sites selected for the Alexa top 1 million. We looked at 500,000 targets for IPv4, only 300,000 targets for IPv6, but the picture emerges quite clearly. So the first bit of good news is that from these target locations, which are arguably not ISP edge locations, we know that, but from these locations, most of the paths got path MTUs greater than 1,500 bytes, and that applies for IPv6 also. 96%. That's great. So what happens to the remaining 4%? Then it's slightly sadder answer. For the remaining 4%, path MTU discovery works well with IPv6 for 0.05% of cases. So in these 0.05% of cases, we received a PTB message from a router on the path telling us the new MTU it supported, and the old style path MTU discovery worked and gave us the right answer, and the path validated, and that was great. For about 0.07%, we got a PTB message back from a router on path with a PTB message, but then we still couldn't make the path work. Okay, these are just broken paths. Sometimes the internet isn't working, or maybe the target server isn't actually online that we're trying. So 3.3% of paths didn't give us a PTB message that actually told us a workable path MTU. Maybe they gave us a PTB message, but it didn't actually work because there was another bottleneck further down, or more likely we got no PTB message at all. The good news is that if you probe these paths with a packet probe using DPLP MTUD, RFC 8899, then you could get a path through. So path MTU discovery using PLP MTUD would help. But PLP MTUD relies on sending successive probes. So you can't discover this in one shot, you have to use multiple probes to get there. And the idea behind the hop by hop option is that you can send a discovery packet and avoid all that number of probes. Particularly if you want to get a big MTU, that saves you many, many RTTs. So good news and bad news. Bad news if you talk about PMTUD for IPv6. Lots of people implemented it, but few routers actually give you the information you need. PLP-MTUD
By the way,
helps.
there is a poll going on in the background about people, how many people have read the draft. Please fill it in.
Welcome interruption from Bob. Yeah. Do I tick it? Next slide.
Sorry
please.
to interrupt.
You're welcome, Bob. You can do the slides if you like.
No, you're good.
Next slide then, if we're... Oh, we got it. Larger internet MTU. So my ambition in life, partly, is that we get to use these really big frames that Ethernet actually provides, even though the IEEE haven't standardized them. Because we know many line cards actually support large MTUs, and we know many servers have them, and many client operating systems support these. So what's our chance of using them? So I had data that showed tests from the edge, looking at the Alexa top 1 million, and it wasn't very exciting. Most of them supported 1500. Very boring. So why might that be the case on end-to-end paths across the internet to web servers? Well, one place to look is perhaps in the peering database. What do internet exchanges actually advertise as an MTU? I mean, you've got to get your packets via an internet exchange in most cases. And the answer is 38% in peering DB use a default MTU. 51% use a 1500 byte MTU, probably the same advertisement actually. So only 7% used a 9 kilobyte MTU. Well, okay, I mean, you could take that good or bad. There is a 7% of IXs, internet exchanges, actually support a big MTU, so that's pretty good. It might not help you in general. We don't have ISP data, and I suspect if we had ISP data, we'd find that many ISPs at the edge give you 1500 or slightly less. We know that from previous work. So this isn't really a complete data set, it just shows where one of the bottlenecks is. If you're into content edge services, and you have data for the MTU get to the content edge, to Akamai, to Cloudflare, etc., we'd love to talk to you. That would be fun. What's our takeaway for the hop by hop option? Well, there's promise. Some paths do provide a big MTU. And if you've got an ISP that will support it, then you could use it. So it might be useful in the internet. Next slide. There are other issues. Let's look at extension headers themselves. If you could use the hop by hop option to discover a big MTU or even just a small MTU, how many paths support extension headers? Well, we did quite a large survey, but we used a DNS server as target, so UDP packets to a DNS server. And of those paths, about 30% of the paths supported the extension header. Again, it's not a bad piece of news. It's probably an expected piece of news. We probably want more data to other types of servers. And we presented that data last IETF. So for next IETF, we'll have a better set of data. We could dig into 2 of our probes and tell you what happened for 2. One was in the UK, which appears to be quite a good place because the extension headers work fine. The service provider forwarded them. We could probe the internet from a home residential router. One of them was in Bob's house. We talked about last IETF. The operator was Comcast. I'm really helpful that we had a conversation with Comcast to find out exactly what was happening. And the news was summarized in this quote here. So I'll read it so that I don't misrepresent what they said. The routers punt extension headers to the control plane. The control plane bandwidth is limited and can be impacted if excess transit extension headers traffic is forwarded. In current implementation, that means it's a good to filter transit packets that contain extension headers to protect the control plane capacity. If you're in V6 Ops, you probably saw this same thing being discussed there in the draft I put at the bottom of the slide, and it talks about more detail of why that might be the case. We looked also into firewall code, and we found that, at least for the firewalls we looked at, the default action was to filter packets with extension headers. Since most web servers lie behind firewalls, that might also give us an indication of what happens when we probe web servers. So we plan to look more at the edge, see where extension headers work. At the moment, if you want to use the extension we are advocating in this draft across the general internet, it may or it may not work. That in itself is not a disaster. When it works, it provides extra information. When it doesn't work, just be careful not to use it on a packet that you really care for. Use a probe packet to carry the extension header. Or you could use it in the general internet. Yeah, well, obviously we're looking for more people to look at this problem space because we'll be doing extensive measurements in the next period. And we'd love to talk to you. Next slide. Oh, next steps. Yeah, that's where we got to. So we have a working piece of code in VPP that adds the field, modifies it, updates it, sends it on. So we have one router that could do a proof that we can actually do something here. We'd love more people to implement this. Really love to talk to you and see if we could do something. The target place where this is most useful is likely within the data center. Within a data center, big MTUs often supported, the switches often have the support, the routers might well have that support, and this would actually be a big win to letting you immediately verify that the configuration of the devices on path matches what you expect. So, looking for people to implement the router side, we're also looking for people who are interested in the host code. You can use this in a very simple way and get the information out about your path. Would people be interested in talking to us about that? We'll do that experiment as well. Please talk to us. New data for March. Please read this version. If I've said nothing else that's useful, the version now is really readable and we don't know how to improve it. So please tell us. Is that my last slide? Oh,
it's
questions,
almost, well,
comments?
yes. So please come to the microphone. So while we're waiting for people to come, well, here we have Ron. Ron, please go ahead. Oh, it disappeared again. So Gori, how do you see the, do you want to see implementations of this sort of in parallel to this document being advanced while the experiments go on, or do you see any issue with, from my perspective, this looks like we're almost done, right? That we could push this document forward and publish it. But Yeah, what do you prefer? What do you see as the most successful path here for getting both deployment and publication?
I'll talk first, and then I think Bob should talk because I don't know whether we agree yet on this. But if people want to implement this right now, I would love to talk to them, because the more experience we get sooner, the better everything's going to be. So no, I would happily delay publication if there was active work to get this implemented and get the experiments going with this. Then maybe it doesn't have to even be experimental. Perhaps I could push you to do a PS because we actually knew about it. If that doesn't happen in the next IETF cycle, I think I'll be asking to publish anyway, because the experiment is very clearly defined from my side. So I would love to try and push this along, but I'd happily delay that a little bit if I saw implementation work.
Yeah, that
Yeah,
makes sense,
and-
Bob.
Yeah, and I agree with that.
Any other comments from the working group on this? And if anyone wants to help out in the experiment by hosting probes, I guess, Gori, you are the contact for that, right?
Yeah, we will put you in touch with Anna, who's very helpful, and Anna has a virtual version of the probe as well, which runs in a virtual box, so you don't actually have to take hardware.
Right. So we could have a very large number of probes. And it would also be good to get probes in some environments with larger MTUs, maybe like several inside of a particular ISP or cloud provider. Andrew?
Andrew, yeah. Have you unmuted yourself, Andrew?
Wanted to check with regards to those virtual probes, any particular hypervisors, anything else before I chase you up on this?
That's an easy answer. Please email us. It's probably better to talk to Anna, because she could. We can put you in touch, and she will quickly tell you what's involved. She has a quick fact sheet, and you can talk about which hypervisors, etc., work.
We could probably also
Thanks.
send that out to the list, unless it's some reason not to.
Indeed, I think we can. We would just love to get more measurements.
Cool. Okay. Super. Thank you, Gori. Then we're on to the next presentation, I think. Unless, Andrew, are you still in the queue, or I guess not. Super. So Giuseppe, you are up.
Yeah.
Let me just get your slides.
Can you hear me?
We can hear you.
Okay, good.
You're a little faint, but otherwise we can hear you.
Okay. Can I go ahead?
Please
Yes,
go ahead.
Go ahead.
Hello, everybody. This is an update about our draft on application of alternate marking. So next slide. Yeah, just a quick recap regarding the methodology from whom is not very familiar with this kind of methodology. So alternate marking allow a passive performance measurement technique to measure packet loss delay and delay variation. The reference document is the FCX321. The basic idea is to batch the packets based on time interval or number of packets due by switching the flag. In this way, you can create the bench of packets over the network. For single marking, you can use the first and last packet to measure the delay variation. Otherwise, you can add one more bit, and that's why we are asking for 2 bits, that is the delay bit, that can be used to select some special packets that are dedicated for delay and are fully recognized over the network. So next slide. The evolution of the basic alternate marking is presented in the RFC 321. Has been just published in the new RFC, that is RFC 8889. In this case, the alternate marking is extended for multi-point flows. In this case, you can also monitor the full network, or otherwise you can select the subnetwork to monitor at different levels. This allows a flexible performance management approach. So you can go to monitor a subnetwork up to a single flow or a single link. This is to introduce a flexible approach to the performance measurement. In this case, the packet loss can be measured on multi-point path basis or considering the single flows and the single link as in the RFC 8321. In same way, the delay measurement can also be done on multi-point path basis or on single packet basis. So this is the flexibility is that you can decide based on the degree of detail you need. Next slide. So basically, to apply this methodology in IPv6 world, we need a marking field. So this is the requirement. In this regard, we are requesting an option header that can be an op by op or destination based on the type of performance measurement you want to enable. In general, the source node is the only one that writes this option header to mark the flows. Both the intermediate or destination nodes passively receive and read these bits to perform the measurement, but they do not modify modify any field of the option header, both in the case of op by op and in the case of destination option. So next slide. Yeah, this is the data field that is defined in this graph. The so-called alt-mark option is expected, as I said, to be encapsulated as op by op or destination option. The usual TLP format is showed in the slide, and you can see the 2 bits, L and D bits for the marking field, and the new flow monitor identification field that we are introducing. Next slide. The reason for the introduction of this flow monitoring identification field is requirement for implementation reason, because to allow a flexible measurement, you have to reduce the per node configuration in order also to increase the number of flows that you want to monitor. And the use of ACL is limited, so that's why it's better to have an identification field in our TLD. In addition, it also simplifies the counter handling, and also it facilitates and it eases the data export. So next. Yeah, we had also some discussion about the uniqueness of this field, because it can be set by a centralized controller, and the controller can instruct the nodes in order to guarantee uniqueness of this identifier. Otherwise, it can be randomly generated by the source node, but in this case, there are some possibility to have a collision, a chance of collision. For example, if we are going for 20-bit flow monitor identification, there is a 50% chance of collision for 1,200 flows. So for more entropy, in many cases, we suggest to combine this identification with other identification flow information in the packet, or the size could be increased using reservoir fields or in some other way. Next.
Oh, and by the way, I started a poll for how many people have read the draft.
Okay, thanks. Thanks, Bob. Regarding the alternatives, you can see all the alternatives that are on the table. So you can use the destination option to measure only by node in the destination address, the op by op option for every router on the path, or you can combine the destination option plus any routing header, for example, SRH. In this case, you are monitoring every destination node in the route list. You can prefer, in general, in many cases, end-to-end measurement is not enough, so it could be required the op by op measurement. But even if for op by op, I know that there is some discussion about the applicability, and in any case, there is no problem, because even if an on-path node is not configured to read this option, the op by op is made only for the nodes that are configured to read this option. So this does not affect the measure. Next. Yeah, regarding the security considerations, so there are of course some security concerns, but are limited because the alternate marking implies modification on the fly to an option header. So, but in any case, the information is very limited, and this must be performed in a way that does not alter the QoS experience. Regarding the help to the measurement, we are in the context of a controlled domain. So the network node, it is supposed that the network nodes are locally administrated, and this type of attack can be avoided. In addition, an attacker cannot gain the information by using one single monitoring point, but need synchronized monitoring points. So this increase the difficulty to do this kind of attack. Regarding the privacy are also limited because the method only relies on information in the option header without any release of user data. Next slide. Yeah, the change from the last version, we addressed the comment from Ron about the timing aspect of this methodology, because he has some concern about the resiliency of reordering, but there is a mathematical formulation in both RFC 8321 and RFC 8889 about that. And we also include a small paragraph that describes how the alternate marking is resilient to this kind of reordering. Another comment was about the possibility to pick up one of the bits for cross-layer telemetry information, for example, QUIC and TCP. In any case, this is considered out of scope for now and could be evaluated in future when this QUIC TCP measurement will be also accepted in the relevant working group. We can also discuss this cross-layer telemetry information. Next. I think it's the last one. Yeah. Regarding the next steps, yeah, we can say that we have found an agreed way to apply the 2 RFC to IPv6. We have requested the IANA. We want to request the IANA parameters to test the implementation, and of course, the questions and comments are always welcome.
Okay, thank you, Giuseppe. Any comments on this draft? So Giuseppe, have you made an early request to IANA?
Not yet, because maybe we need the approval from the chairs, right?
Yeah, I think the process is you basically ask us first.
Okay.
Yeah, we can send you the details. There's sort of a bit of a form to fill out, and we can get that started. Eric Klein, just
I will wait for
put a link in the chat. And I guess the other questions, I mean, so this is a working group draft. When do you think this will be ready to advance?
I think that in terms of content, it's quite stable. We may discuss if we want to put some implementation details, or we can. But in terms of content, I guess it's quite stable. Maybe we have to refine something again, but it's quite stable.
Okay, so it sounds like you're not quite ready, but maybe soon. Yeah, it would be good to see this progress.
Okay.
Good. So the results of the poll showed that 19 people have read it, and 8 people said they didn't, and 74 people didn't respond. So,
Okay.
which is better than the other drafts.
Good number.
Yeah. Okay. Well, good. Thank you.
Thank you. Thank you.
Well, I think, unless I'm forgetting the agenda, I think we are done.
It's just to wait until Prague then. Hopefully we'll try to make some progress between now and then. If things have come up, I guess the barrier to do interim meetings is lower now than normal as well. So that's certainly something we could do if it's required. But otherwise, we will virtually see you in Prague.
Yes.
Gori has a last word. Please go ahead, Gori.
Sorry, I'm very slow at pressing the right buttons. No, I just wondered whether people were actually reading the drafts and not able to use the tool. And maybe we just have to try and get eyes on the drafts and get people to say that they've read things.
Yes, I think we can't conclude anything from sort of the hand-raising tool exercise. I guess we could have run them as we do hums, where we declare the hand-raising session for open and keep quiet for a minute and wait instead of running it in the background in parallel.
Well, we could try that as an experiment. I can start another one. Hold on, let me type it in.
So we're now going to do a poll on how many people have read the PathMTU discovery draft.
Oh, no, I was doing the alternate marking, but I'll change it.
Oh, right, okay. Yes, let's
go.
do. So for the alternate marking, we got 20 had read it out of, and 8 didn't, so it's a higher score than that one.
Okay, so I started a second poll for the alternate marking. One thing I've discovered is it's good to type the name of the draft when we ask these questions, because then you can tell what the results mean afterwards.
And I guess we will not end this session until we have 72 answers. Or sorry,
we
yeah.
could have another outcome. We could have everyone leaves and then we have the right number of answers.
That's right. I wonder why we have 78 participants and only 72 in the hand tool.
Yeah, it's by the way,
Cool,
it's
sort out
counted
this
twice
thing.
in Java.
Oh,
Say that again?
Yes.
Saying that Meteorco will certainly see the end of our poll if we don't take it in time.
Yeah, so we are getting more we are getting 20, currently 21 and 14, which is better than before.
Yeah. So about
Okay, so
50% response rate at this moment.
right. So
that's quite good.
I'm gonna end this, and then I'm gonna do another poll for the PathMTU. Type. Okay, I have now started that poll. And I have read it. Yeah, we're seeing much higher numbers.
And Gori,
So
a few people have contacted me on the side here asking how they get contact details for Anna. Perhaps you want to send out an email to the list as well, asking for probe volunteers and provide contact details. And if you have any any limitations of what kind of networks you want people to have. I was
Lovely.
going to
We'll do that.
call my ISP and ask them to increase my MTU to 9K, and see what happens.
Good. Yeah, so the numbers here are slight. Went up and went down, slightly better, 14 and 12 out of 71. So I think it does work better to just call the question, you know, before or after the talk than to do it during the talk. Or else maybe it works better at the end of the session when people are tired, want to go home. But okay, well, good. I will end this. Well, good. So I think we will thank you all. I think it's been a good meeting, 2 sessions. 2:20 in the morning for me. Some of you are in better time zones. So thank you all very much, and we will see or hear you on the list, and hopefully in wherever the next IETF meeting is. Probably not face to face, but maybe in the fall we will get to meet again in person. I hope so. So thank you all, and good night or good morning.